So here I am in Desmos again, and I have graphed a polynomial. F of x is equal to x cubed plus 2x squared minus x. Now, the really cool thing about Desmos for today is that because I have told Desmos the name of my function is f, Desmos can actually graph the derivative of this function for me. So here in blue is the function f prime of x. And I can check that all of my ideas about derivatives are graphically being verified here. So everywhere that the blue function is equal to 0 is a place where the red function should have a horizontal tangent line. So when x equals 0, it looks like, why, yes, my cubic does have a horizontal tangent line. And here again at x equals about 0.2, I'm expecting the red function to have a horizontal tangent line again. I didn't draw them in today, but we can imagine them. Also, I can see that in all of the places where my blue function is below the x-axis, those are places where my derivative is negative, or equivalently, those are places where the tangent line has negative slope. Why, those are all x-coordinates where the red function is decreasing. A decreasing function has a negative derivative, vice versa, and an increasing function has a positive derivative. So as long as I'm choosing x bigger than 0.2, 0.21, then my red function is increasing. It's also increasing over here. And I can tell that because my derivative is positive. Well, cool. There's some graphs of a derivative. But, you know, with Desmos doing the heavy lifting, it's obscuring what that derivative formula actually should be. So what I'm going to do is I'm going to say, let's calculate this derivative in pieces. My formula says that I'm allowed to calculate derivatives of the different pieces as long as they're added and subtracted from each other. Then, to get the formula for the actual derivative, I just have to add them or subtract them accordingly, right? So however they were combined to begin with. So let me have y1 here be equal to the derivative of x cubed. Well, I know from the power rule, I bring down the old exponent of 3, and this will be multiplied by x to the power 2. I bring down the old exponent, and my new exponent is 1 less, than before. Well, this showed up in green now, and that's not the derivative I had in blue. That's not quite it. Let me turn that off just to get it out of the way. We'll come back to that in a bit. Let's try y2. y2 is going to be the derivative of twice x squared. Oh, well, here I need to do, what do I need? It's my constant multiple rule. So let's bring that coefficient of a 2 off to one side for a bit. I know that my derivative of x squared is 2 times x. So the derivative of 2 times x squared must be 2 times x. Or how about 4x? All right, so this is now graphed in purple, and that's a line. That's still not my derivative, right? My derivative is this nice blue parabola. Keep going. The last piece I have here is this x, and that one is super duper simple. I know that the derivative of x is just 1, again, from the power rule. My exponent is 1, I bring that 1 down, x to the power 0 is 1, and I get, oh, this isn't showing up as well. Let's say for minus 1,000 to 1,000. Come on. It still misbehaves sometimes. Right. So there's my function y3, or maybe my g of x is equal to 1. This is the derivative of x. It's definitely not the derivative of my red curve, right? I'm still not getting that parabola. What the sum and difference rules tell me is if I want to calculate the derivative of f of x, then I need to take these three separate pieces I calculated and combine them like so. I will have 3x squared. I will add to that 4 times x, and then I will subtract 1. I'm just following the operations from the way they were combined in my original formula. I've taken the derivatives separately. The derivative of x cubed is 3x squared. The derivative of 2x squared is 4 times x, and the derivative of x is 1. So subtracting my x, I get minus 1. And now, that matches my derivative exactly. So this is the formula of my derivative. F prime of x, here drawn in blue, is equal to the formula 3x squared plus 4x minus 1.